Hello there. Today we'll be doing permutations. This problem is going to be done using the UMPIRE method, and this means that we will be understanding the problem first. This results in a understanding of the test cases, edge cases, and time and space complexity. So for test cases, we have several here in the examples, and so we're going to take this 1, 2, 3, and there are 6 different permutations. With the 2 items, there are 2 permutations, and with our edge case, our minimum is 1 and maximum is 6, so those are our edge cases. So let's go with a single item. I don't see how the 6 items are different from 3 items, so let's just take a single item. And with that, we are looking at the space-time complexity. So how is this going to work? Well, there are 3 selections at the first spot, and then there are 2 remaining selections after their one's chosen. And so this basically means that there are 3 times 2 times 1 options when there are 3 items, and there are 2 choices with 1 item and 1 choice with 1 item, and that is proven here. Okay, so there are 2 options and 1 option, as seen in the test cases. So this is perfect. We're going to take an n for time, and we're going to take an n exclamation for space. With that, we are done with the understanding, and let's move on. So let's get some more space here and move on from our understanding and into the plan. Into the match. The match that what I would choose is going to be backtracking and recursion. So what this means is that we're going to move everything around. We're going to select the first one, and we're going to select the second one, and then we're going to select the third one. Then we're going to go back to the second one, move things around, then move forward again, then select the last one, and then find our output and submit it. So here's my plan. Is that we will select the first option n times, second option n minus 1 times, and first item and second item, and take the last item 1 time. Alright, and with that, we are good with our selection. And once we recurse to our last selection, last item, pass the last item, let us update the results with the new permutation. Okay, that is the plan, and let's implement it. Okay, the implementation shouldn't take too much time. Alright, so implementation, here is a define, backtrack. We're going to take the first and set it to 0. So what's going to happen here is, well, if first is equal to n, which is the length of numbers, results, we're going to append nums at, this is a copy of the nums, and we're going to return. Otherwise, what will happen is that we will take a backtrack after swapping the first and the next item for I in range from the first item till n, the last item. And so that's where we're going to do the swaps. So then we'll do a backtrack and get the next item. So with that, we'll be swapping every single item from the first all the way to the end, and we'll be swapping the next item will n minus 1, and so on and so forth until the last one. This swaps it back when we're done, and this is our backtracking function. So that's all. So results is equal to empty array, and our, well, n is equal to length of nums. Then we run the backtracking function, and we return results, and we are done. So let's review. Okay, I'm going to make sure everything is in the middle of the page so that we don't end up losing information. So we're going to use this first test case, and with this test case, I think we should be good to go for all the other test cases because, well, yeah. But the reason why is because the 1 through 6, they're no different because we'll have to do the 1 eventually too. And yeah, so let's go for it. With the review, I think we should have set our results. We should set our nums. We should set our n equals 3. We should also set our stack of recursions. So start at backtrack at 0. This is the third line of code right here. So first line of code, second line of code, and third line of code. Okay, so now we have backtrack 0. So backtrack 0 is first equal to n. That's not true. 0 is not I. And we're going to set I. I is going to start first, which is 0. Okay, then we do a first swap. So 1 swaps with 1 right now. And basically, this does no swapping whatsoever, as you can see. So now we do backtracking at 1 at the second line of code. So 1, I starts at 1. So this swaps with itself. Nothing occurs. Then we swap at the third item. So nothing occurs once again. So with that last swap, we're going to do backtrack at 3. With backtrack at 3, this first is now is equal to 3. So this means that we can append this nums into our results. That's our first item. Now, with that, this is gone from our stack because it has returned. And this nums, backtrack 2, basically redoes the swap at I and first. With that, we are done here. We no longer have any work to do because the loop is over. And now we're down to 1. With 1, we do still have some time to go until 2. So I is now equal to 2. And first swaps with I. So basically, F is at 2 as at 1, and I is at 3. So we swap those 1, 3, 2. And now with that, we take our next item and we run the backtrack here after the swap. And we have 2 at 2i. So now we go to backtrack at 3. With backtrack at 3, we append this result, this permutation, into our results, and we're done here with this returning, this swapping back 2 and 2, as you can see here. And we're swapping the first and this I back with this function, and we are done. Now I moves back to 0, and we do a 1 increase. So first is at 0, and I is now at 1. With I at 1, we swap those, and with that swap, then we can backtrack. So 2, 1, 3. With that, we start backtracking again, and we have backtrack at 1 and 1. So nothing happens, as you can see. And then we have 2 and 2 again. As you can see, we run this code, and our only item possible in this range is a 2. And with that, now we do backtrack 3, and there's nothing there. So basically, this means that we can append this to our results. We are building up our results quickly. As you can see, there were 3 options that we can select here and only 2 options that we can select from the rest. Now that is done, backtrack 2 is done, and now we're down to 1. 1, we switch I equals 2, and we do a little swap between the first and the I number, and 3 and 1. Now we repeat the same items, and there is no swap with the next I because the last items, there's only one way to arrange the last item, and now there are no more ways to arrange anything at 3, and so that means this is, well, appended. And with that, we have 4 options down. Now we have a few more left, as these are complete. This is complete because this swaps with the same item. This swaps with 3 and 1, so we swap that back. And now we are back to, and this is done with this function here after swap back. And we are going to swap this item back 0 and 1. And then swap that back. With that complete, we can move the I forward. And we're getting down to our last item where we swap the 3 and the 1. With that, we are ready to do backtracking at 1. So backtracking at 1 is going to select this first item. And so basically nothing changes, and we're going to backtrack 2. Backtrack 2 is the same item, right? And basically nothing changes. And now we can run backtrack 3. With backtrack 3, this means that we are done here, and we can submit this item into our results. So now let's put this in our results and complete this backtrack 3. And backtrack 2 is done, and we swap everything back, same item, same place, and same with 1, same item, same place, put that back into order. So now I is equal to 2, as you can see. It is not complete, so I is now 2, and we swapped 1 and 2. That is our last item. So with this swap, let's backtrack forward again. Backtrack at 2 at this particular line of code, 2 and 2, and go in to this loop and do a swap between 2 and 2, and nothing happens. Now, basically, with that swap, we can backtrack to 3. With 3, this is going to be the end of our loop, and it basically means that we can append this as our last permutation into our results. With that, this is done, and once it reaches the end, it swaps with itself, and that's done. Now, we're looking at 1 and 2 as our first, and we basically swap these back, and we reach the end of our loop, so this backtrack function is done, and now we're down to our last item, which is we're going to swap everything back at this particular point in the code, and 1 and 3, because first is at 0 and I is at 2. So with that, we finished all the entire loop, and we have all of our results, so we can return this as our output, which result gives us a good answer. Now our evaluation of the time and space is going to be n, exclamation mark. As we have seen, there were 3 options at the beginning, now 2 options, and then 1 option. We multiply those, and we get 6. And space is going to be n, exclamation as well, because it took that many different permutations. So perfect. With that, we are done with this problem. Let us submit it just for double checking, and we're good to go. So let me just put this into our lead code and finish it off. So let's submit. Perfect. So I hope you enjoyed this video. If you want more videos, check the link in the description below. If you have any questions, comment, and hit that subscribe button for more. So I'll see you in the next one. Thank you. Bye.